All right, so we're going to work on simplifying radicals today. So first thing you might be wondering is what exactly a radical is. Well, the radical is the symbol up for a square root. So last year you guys worked on things like maybe square root of 25, and you learned that that was 5, or in fact it could also be negative 5, because this number squared will give you the square root of 25. So you also learned that like the square root of 100 would be 10. So in simplifying radicals, what that means is that we're going to be reducing, because simplifying is reducing. So we're going to be reducing square roots. So last year in Math 8, you guys did go through and estimate square roots, but we are not going to be estimating this year. We're going to be simplifying. So the process is a little bit different. But basically all we're doing is reducing. All right, so here we go. Let's start with, so for example 1, let's start with something not too bad. Let's do square root of 12. All right, so what we want to do is we want to break 12 into what we know will multiply to be 12. So I know that 12 could be 2 times 6. And then I can break 6 down further to be 2 times 3. So what you want to do is break the number down into its factors. So you want to go all the way down to the prime factors on that one. Then what we're going to do is we're going to look for a pair of the same number, because taking the square root of something means that you multiplied a number by itself. So right here we have a pair of 2's. So that tells me that I can bring a 2 outside to show that I had a pair of 2's. So that comes outside, and this 3 is left over inside. So 2 root 3, or 2 times the square root of 3, is the reduced form of the square root of 12. So basically what we're doing is we're pulling out any perfect squares that we have, and then that way we have the simplest, the most reduced square root possible. So just to show you another way to do the same problem is if we had the square root of 12, we could break that into 4 times 3. Well, I know that the square root of 4 is 2. So that's another way that I know square root of 4 becomes 2, but the 3 is still left inside. So that's another way of looking at the same problem. All right, here's another example. So for example 2, all right, so let's say we had the square root of, how about 75? All right, so I know that this would be 3 times 25, and I know, for one thing, I know what the square root of 25 is, but let's pretend you didn't. We can break that into 5 times 5. So the prime factors here are 3, 5, and 5. So basically what's happening is the square root of 75 is the same as 3 times 5 times 5. But right here we have a pair of 5's, so that can come outside. So when we pull it outside, that tells us that we had a pair of that number inside. So the simplified answer would be 5 square root 3. All right. How about, let's see, let's try, for example, 3. Let's try, square root 24. All right, so we got to think about what would multiply to be 24. And there's more than one way to break this down. So I know that this would be 3 times 8. I know I can break 8 to be 2 times 4, and I could break 4 down to be 2 times 2. So I end up with that the square root of 24 is the same as 3 times 2 times 2 times 2. So that's the same thing as 24. So now I'm going to go through and I have one pair of 2's. So on the outside, I have a 2, and on the inside, I have 3 and 2 left over, so they just get multiplied back together. So we end up with 2 square root 6. All right, next example. Sometimes you might have a situation where the square root already has a whole number outside of it. So let's say we had 4 times the square root of 72. All right, so first thing we need to do is work on 72. So I know that's 8 times 9. I know 8 is 2 times 4. 4 is 2 times 2. And 9 is 3 times 3. So to break this down, we have the 4 outside, and then in the square root, we have 2 times 2 times 2 times 3 times 3. So this right here multiplies to be 72. So now I'm going to look for pairs. So I have a pair of 2's, so a 2 can come out. I have a pair of 3's, so a 3 can come out. So to get the answer, all of this is multiplication. So outside, I have 2 times 3 times 4, and all together, that multiplies to be 24. And on the inside, I have left a 2. All right. Next up, let's take a look at what happens when we involve variables. So variables are, of course, you know, are the letters in our problem. They're done a little bit differently, but it's still the same idea. So I forgot. Okay, this is example number 5. So for example 5, so let's say we have 3 square root, how about 48 m to the 5th? All right, so first thing I'm going to do is break down 48. So that's 4 times 12. And then I can break 12 down to be 4 times 3. Now, I'm going to pause here because as you guys get better at this, I can already see that I have a pair of 4's. So I don't really need to break it down into 2 pairs of 2's. I already know that there's a 3 outside, and then inside I have 4 times 4 times 3. That'll save you a little bit. Now, you don't want to skimp too much, but anytime I have 2 of the same number, I know that that means I have a perfect square and it could come outside. So 4 times 4 times 3 is the same as 48. So I'm going to look for pairs. So I have a pair of 4's, so I can bring that outside. So now I have 12 on the outside, and I'm going to leave a little space on purpose. And then I have 3 left on the inside. So now I'm going to take care of the variables. So if we kind of think for a second, m to the 5th, so m to the 5th means that we have m times m times m times m times m. Well, if I have 5 m's, I can make 2 pairs. So that means that I have 2 m's that can come out, and then that's going to leave an m left over inside. So when we deal with variables, we're looking just like we are with the numbers, but we're looking for how many pairs we have. The exponent tells me that I took 2 pairs of m's out, and then there was an m left over that didn't have a pair, so that one gets left behind in the square root. All right, let's try another one of those. So for example 6, so how about 4 square root, let's do 200 a cubed b to the 4th. All right, so now I just put two variables, no big deal. So I'm going to take care of the 200 first. So the 200, I can break that into 2 times 100. And then I know 100 would be 10 and 10. So I'm going to stop there because I could keep going, but I can already see that I have a pair of 10s. So I have a 4 on the outside. And then inside we have 2 times 10 times 10. And then a to the third, b to the fourth. All right, so here we go. We're going to look for a pair of 10s. So I can bring that outside. If I look, I have a to the third. So that tells me I can make one pair of a's, and that's going to leave 1 inside. And then b to the fourth, I can make 2 pairs of b's, and that doesn't leave anything left over inside. So in the end, everything that's left gets multiplied together. So outside, I have 40ab squared, and in the square root, I have 2a. So that's going to be my answer. Okay, remember, as always, if you need to go back and rewatch something, please do. If you need to back it up, if I went too fast, remember you can always pause. And now is a great time for you to do the practice problems, and let me know if you need any more help.